Do you know that at least 1 in every 12 stars exhibits evidence of planetary ingestion? A team of researchers from the ARC Center of Excellence for All Sky Astrophysics in 3D, ASTRO 3D, has shed new light on the mysterious evolution of planetary systems. The study focused on twin stars, initially presumed to have identical compositions due to their shared origins from the same molecular clouds. However, the team discovered surprising differences in approximately 8% of cases. This prompted the team to probe further. Thanks to this very high-precision analysis, we can see chemical differences between the twins. This provides very strong evidence that one of the stars has swallowed planets or planetary material and changed its composition. The phenomenon appeared in about 8% of the 91 pairs of twin stars that the team examined. What makes this study compelling is that the stars were in their prime of life, main sequence stars, rather than stars in their final phases, such as red giants. Stars' evolution needs more in-depth study. They did an in-depth study of 91 pairs of twin stars and uncovered a phenomenon previously thought improbable. Stars in their prime of life, rather than in their final stages, exhibit signs of planetary ingestion. Dr. Liu suggests that stars may either swallow entire planets or engulf protoplanetary material. While the ingestion of whole planets remains the favored scenario, the possibility of material absorption from protoplanetary disks cannot be dismissed. Astronomers used to believe that these kinds of events were not possible, emphasized Associate Professor Yuan Sen Ting, a co-author from the Australian National University. However, from the observations in our study, we can see that, while the occurrence is not high, it is actually possible. This opens a new window for planet evolution theorists to study, Professor Ting noted. The research forms part of the Complete Census of County Moving Pairs of Objects (C3PO) initiative, which aims to spectroscopically observe a comprehensive sample of co-moving stars identified by the Gaia astrometric satellite. Dr. Liu, Professor Ting, and Associate Professor David Yong lead this collaborative effort, which contributes to ASTRO 3D's overarching research theme of the chemical evolution of the universe. Professor Emma Ryan Weber, Director of ASTRO 3D, adds to the significance of the findings in advancing our understanding of chemical element distribution and stellar evolution. The findings presented here contribute to the big picture of a key ASTRO 3D research theme: the chemical evolution of the universe.